But so it's more complicated than just going on a low carbohydrate diet, because we know how to make pigs fat, right? So in that late finishing phase, we can save some money on the protein, but we shouldn't even be talking about protein, right? Because we learned in swine nutrition, we balance a ration for amino acids.
Welcome to MeatsPad. In collaboration with the American Meat Science Association, it's a platform dedicated to share breakthrough knowledge that is accessible to the global meat industry. On each episode, you'll have the opportunity to listen and learn from meat specialists and professionals about the whole meat industry. This podcast is brought to you by the U.S. Meat Export Federation,
U.S. Berg,
Ultrasource, equipment and supplies for the meat and food industry, EFA, slaughter and meat processing tools.
Hello, meat folks. Welcome back to the MeatsPad podcast. It is your hungry and humble host, Phil Bass, yet again. And here we have with us an individual who I've had on my list for some time, and I hadn't had the nerve to do it yet. And so here we are. I know.
I'm so scary.
I know. It's intimidating, isn't it? So Dr. Eric Berg with North Dakota State University. I've been, I don't want to call it a groupie because that's definitely the wrong connotation. But I've been following your work for many years now. You started, and maybe you can remind us all, but you started talking about this idea of using the pig as a model for human nutrition. And anytime I get a chance to sit and listen to you, first off, the information is fantastic, but the jokes are just as good. And so I appreciate your humor. I think you and I are cut from a similar cloth. So,
yeah.
But Dr. Berg, welcome to the podcast.
Hey, it's great to be here. Thanks, Phil.
Yeah. Okay. So what I want to do, first off, I've already mentioned it, but tell us a little bit about your work that you've been doing. You do a lot of meat science work there in North Dakota, and have served our amazing American Meat Science Association for in many different avenues. But I want to focus today on how you're using the pig as a model for human nutrition, and
sure. Yeah, I'm going to start way back and try to draw a connection between meat science and how I got to this point, because it started, with traditional meat science, studying pork quality. And when you're studying that pork quality and the postmortem conversion to muscle to meat, we're taught in our meat science classes about that pH drop, and when you start looking about where that comes from, you start studying how glucose gets stored in muscle because glucose goes through postmortem glycolysis, lactic acid, pH decline. Well, it doesn't take you very long to start looking at the functions of insulin and how insulin clears that blood glucose. And then as you're digging into that research, you find out that it wasn't that long ago that humans were using porcine insulin to treat type 1 diabetes, which we used to call adult onset, or we used to call juvenile diabetes, because people were born with that. And the adult type, the type 2 diabetes, they're both a completely different deal. They both involve insulin. But so that got me thinking about a connection between, diet and insulin resistance. And the pig let me back up a little bit more. I started reading some more and got into a concept in humans called tissue-specific insulin resistance. And really, this kind of drove home for me the progression of chronic disease in the human population and how obesity is just kind of the phenotype or the outward expression of that. So I'll try to do this real quick, but the way that works is that if we're eating an incomplete or an unbalanced diet that's heavier in starches and sugars, you have that chronic elevated blood sugar. And if you're not burning up that energy, putting it in your muscles are using it for activity, then eventually your body becomes saturated. So that liver is that initial storage place. We can put glucose in there, glucose comes out, back and forth. That's what keeps our blood sugar up in between meals. But if the liver's saturated, the muscle has always been a backup. It can store all that sugar. But if the muscle becomes saturated, now all of a sudden a signal gets sent out and you start down regulating those insulin receptors. The insulin receptor on the muscle cell is the keyhole. Insulin's the key. So when insulin binds its receptor, it clears the glucose. It helps to bind glucose to glycogen for storage. But if that keyhole isn't there, if that insulin receptor isn't there, now that glucose in the bloodstream, that blood sugar starts to rise up. So there's our first risk factor. We've got elevated blood sugar. Goes back to the liver. The liver says, "Hey man, I'm already full. I can't take it anymore, but I'll tell you what I'll do for you, body. I'll convert it to triglycerides." So here's warning sign number 2. I've got elevated blood sugar. Now I got elevated triglycerides. And so the insulin receptors on the fat tissue, in many cases, are still viable. So we're getting elevated insulin along with elevated blood sugar and elevated triglycerides. Oh my gosh, I have a diagnosis of prediabetes. However, the fat cells are going to take that insulin, bind the receptor, and that's going to help shuttle the triglycerides into the fat. See what's happening here? I'm feeding the fat cells because the muscle couldn't take that energy. So insulin has another very important property. Besides clearing blood sugar, it helps with protein synthesis. So if my muscle doesn't have a functional insulin receptor, I don't get that protein synthesis. So now we see a progression of body fat and a shrinkage of muscle. And we've seen that pan out in our pig models because you asked me what time it was. I just told you how to build a watch. So
Yeah, no, this is perfect. Yeah, I mean, this is a scientific podcast that happens to we try to boil it down, of course, for our processors listeners that are out there that maybe don't have quite extensive a scientific background, but you hit a lot of great topics, which I'm going to continue to try to use more so in some of my classes because I think you actually boiled it down pretty darn well. And the point being is that you looked at how the body is going to how it reacts to that higher sugar levels, how that's going to and once the stores the initial storage areas get filled up. Think of this as just a room. You filled up those rooms. We got to go somewhere else with it now, because we're still getting that additional sugar in. And so what's going to happen to the body? And so that's, I believe, where you're leading off into next is looking at the pig. And I always kind of joke ever since I heard you talk about this the first time. And I think back to some of my metabolism classes that I took in graduate school. Dr. Terry Engel at Colorado State really opened my eyes to a lot of this because we know how to make a pig fat. And really, if we wanted to know about human nutrition, we just needed to go talk to a pig farmer and do the opposite, right? Which is, I'm sorry, I'm monopolizing the time. So
that's okay. I have a TEDx talk out there, Phil. You can you can go look at it, and it's titled "Eating Like a Pig." So
I love it.
You're exactly on it. But so it's more complicated than just going on a low carbohydrate diet because we know how to make pigs fat, right? So in that late finishing phase, we can save some money on the protein. But we shouldn't even be talking about protein, right? Because we learned in swine nutrition, we balance a ration for amino acids. United Nations, the World Health Organization, and the FAO all say that it's the 9 essential amino acids. That's what should be on the dietary label. That protein label that we have, that protein that we have on there, 10 grams of protein on a whole grain bagel means a whole different thing than 10 grams of protein in a small meat stick, right? Because of the digestibility and the amino acid content. So now see how complex this can get in for humans that have such a variety of food, even in the poorest countries, because they're not balancing that. So if they're in a severe poor condition, we may think we're being really good. We've got all the surplus corn or all the surplus grain. We got to get some calories in these people, but their amino acids aren't being met. So they're out of whack with high carbohydrate, low amino acids. And even in countries like the United States, where we might think we're getting adequate protein, but it's not digestible, or it doesn't have a correct balance of amino acids. That's what's leading to this chronic disease. That's our hypothesis anyway.
So you chose to look at the pig. I mean, and rightly so. And so maybe explain to the listeners why we're using the pig as that model.
Yeah, their physiology, you hit on it. Their physiology is going to react to the foods they eat the same way ours do. They're monogastric, simple stomached animals just like us. And the food and food combinations are going to impact whether they're lean, or so whether you're a show jock showing that show pig that you want really muscular, those guys know how to do that. Or you want some good fatty bacon, those producers know how to make that happen. And since the pig, physiologically is so similar, the heart is similar size. We can use pig arteries as temporary grafts. We can use pig skin. So you can study all kinds of disease conditions using a pig. And you alluded it too. We know exactly how to feed a pig. So now we have a perfect diet. Your diet's different than my diet. Everybody's got a different diet. And to keep a human being on a diet, of pigs will eat the same thing every day, okay? And they won't cheat. So I have the perfect diet, and we did a ketogenic study. We had the perfect swine diet for pigs that were at this stage of growth for this gender, and we replaced the starch, the carbohydrate in the diet, that energy, with beef tallow. So calorie for calorie, same thing, just different energy sources. And then we only had enough money to do it for 4 weeks. But so we monitored their blood profile, and then we looked at their insulin receptors in their muscle and fat to see if their insulin sensitivity in the ketogenic diet improved. And it did. So the muscle of locomotion, where they need more energy, it had 3 times the insulin receptors in that what we use, semimembranosus muscle. So it was very cool. It's very fun. So now we have preliminary data, and we'll hopefully go after some bigger money.
Yeah. So and tell if you can expand on what you were feeding those pigs and what you found, because I remember one particular talk where you were focusing on essentially feeding them hamburgers regularly and beyond just the beef tallow, right?
Yeah, that was the first project we did. So we put them on a low lysine diet to get them fat.
Right.
And then we basically put them on a carnivore diet. So we had a 60-40 blend of ground beef, and I was teaming up with Dr. Hans Stein. He's world-class swine nutritionist at University of Illinois. And I said, "Hey, Hans, what else do we need to add to this diet so that, they'll still be able to thrive on it?" And he said, "Well, that ground beef it's going to be way too much protein they don't need all that protein, from production setting.
Yeah.
And there's a lot of energy there, and some calcium. So we added calcium to that. And we had them on that for 3 months. We were going to do that. It was supposed to be 6 months, but they ate my budget. They ate up to 10 kilos a day of ground beef. And we didn't drain the fat off or anything. And everything I read said that pigs will regulate themselves once they've met their energy and their amino acid needs. They didn't. They kept going and going and going. So we have this. I've been asked a lot about carnivore diet. What do you think about the carnivore diet? And I said, well, we've done that study, but when you're over consuming protein, you remember from your biochemistry that if your body's not using those amino acids for making muscle or enzymes or hormones, well, they call them gluconeogenic. There are amino acids that can get converted to glucose. So if they're over consuming protein, actually that group did have a higher circulating blood glucose. But once again, their insulin receptors went crazy. So they were very receptive. And then over that period of time, the ones that were on the carnivore diet, basically, they lost body fat.
The mission of USMEF is to increase the value and profitability of the U.S. beef, pork, and lamb industries by enhancing demand for their products in export markets through a dynamic partnership of all stakeholders. Simply put, USMEF is putting U.S. meat on the world's table.
How about that? Yeah. Well, and I mean, there's entire huge bodies of research out there that we could go down into, and that's not the point of this podcast, obviously. But um, talk a little bit more. Is that the project that you had the control that was on a solely plant-based?
Nope, that was the second one.
That was the second project.
That was
Okay.
the next one. So I had a collaborator from Utah State, Corey Hintz, and he's a human nutritionist, PhD, but master's degree in ruminant nutrition. So he comes from an animal science background, and then went on to the human side. And he made a what he calls the total Western diet that he comprised for lab rats, lab rodents. And I contacted him and said, hey, you want to team up and we could do that for a pig diet. So we put together a total Western diet based on the NHANES, the National Health and Nutrition Examination Survey, and put together this diet. And we fed it on a per body weight basis. And the funding agency we had was from the beef checkoff. So we replaced the sugar in that total Western diet with beef protein. So we cooked hamburgers again and added that and took the sugar out. There was still starch in it, and it was still a really poor diet. See, we almost had the bleep button ready to go there. And so neither diet was good for pigs. Okay. So that one we fed again for just 3 months because we had to stop early, and I'll tell you why. But the pigs that were on the total Western diet, what Americans eat, they basically stopped growing, got fat, and their muscles shrank. Just like I was talking about with the tissue-specific insulin resistance. Okay. Also, their hair fell out and they got acne all over them. Okay. These are all prepubertal gilts. We teamed them up. We pair fed them so that they got calorie for calorie, in most cases with litter mates. So they had sisters. And the ones that had the beef in the diet, their muscle wasn't stunted. Think of when you see like a dairy calf and how that muscle looks. The ones that ate the Western diet had a distorted longissimus muscle. It was flat and kind of tapered. And it was chock full of marbling because the insulin receptors were still good on the fat cells. So we were getting fatty muscle disease. Fatty liver disease is a condition in humans. The livers had a little more fat in them in that same group, but it wasn't statistically different. They were a lot paler. Getting back to the ones that had the beef in the diet, they didn't gain any extra fat. They had much larger loin muscle area. They didn't have as much marbling in there. But both groups, because the minerals were so out of whack in the human diet, they both developed brittle bones. But what was weird is they developed brittle bones. One group, I forget which, one group had the brittle bones in the humerus, so at the front end, and there was no difference. And then the hind was fine, and then it was the opposite in the other group. So it was placed different. But we had to stop in that group, they kept their hair. They didn't get as much pimples. Neither group reached puberty. They were all prepubertal. But so it was basically a crappy diet, and beef couldn't save it. And we had to stop it because it was inhumane for pigs. Their bones got too brittle.
Yeah.
So that's what we eat.
I know. That's the telling thing. That's what I want to eventually get to is what have you observed and what recommendations could you provide right now to our listening group that meat in a diet is a good thing? And maybe this kind of goes to some of your discussions on how the labels need to maybe change.
Right. Yeah. Well, when people ask me about should I go on a carnivore diet, I think that's that's a bit extreme. And should I stop eating potatoes? I think that's a bit extreme too. We grow a lot of potatoes around North Dakota, and
Yeah. And as well as Idaho. Yeah.
I don't want to get run out of town. But so again, we talk about balance, but if you're in a overweight or an obese situation, there may be a period of time you could go on a keto diet. There may be a period of time that you could do a carnivore diet. I'm hesitant, given that the overconsumption, there's some link between the bones and overconsumption of red meat. I haven't put my finger on that yet, how that works. So I'm hesitant to tell people, even in an obese situation, to severely eliminate food sources.
Right. Yeah.
I will always recommend whole foods, and kids are going to be eating cereal. They're going to be, my kids, I tell them that, okay, if you're going to eat that cookie, you got to have some kind of protein with it, because if you're going to spike your insulin, I want to have some amino acids there. They're going to build some muscle on you. Okay, so you can't have your pudding if you don't eat your meat. So, I guess to
They had it
quote a
figured
famous
out, huh?
song there.
I love that. Yeah, and I agree with you wholeheartedly that, balance is very, very important in any diet. Definitely in the human diet, there are always going to be those situations where we can, for short terms, maybe adjust that balance in order to get the body back into balance. But yeah, still having that meat in the diet is going to provide that proper balance of amino acids too that we're looking for, and that's where I want to kind of start looking at landing this plane, is talk a little bit about some of the suggestions that I think you've made in the past about, and you've already alluded to this, about that the protein label on nutritional labels, and how it's too broad. It's painting in huge broad brushstrokes where humans are far more complicated than that.
Yeah.
Animals.
I do a demonstration with bagels. Okay. So I'll find a high protein bagel, and that'll have 10 grams per serving. But to get that 10 grams, it's a 2.5 serving bagel or whatever. So it's a big bagel, but it's a whole grain bagel. And so we talk through that, and I say in America, we're kind of a snacker society, and said, I hold up a bagel. How many of you has this been your breakfast before? You're at the hotel and you get that continental breakfast, you grab a bagel and a cup of coffee and you're out the door. Okay. So what else do we have for breakfast? So beef, what for dinner? What's for breakfast? Ham. How about ham?
Yeah.
It's a good lean source. So we do 100 grams of bagel, 100 grams of ham. So on a crude protein basis, you've seen it. Everybody's seen these things. So it's 2.5 bagels to get the same protein that's in that 100 gram, 3-ounce piece of ham. Okay. But that bagel is only 42% digestible. So now you're up to 5.5 bagels to get the digestibility of crude protein. Okay, but I already told you it's not about crude protein, right? It's about the amino acids. So the limiting amino acid in there is going to be lysine. And now you're going to have to eat 22 bagels to get the lysine that's in 100 grams of that ham. It's a ridiculous comparison, because nobody's going to eat 22 bagels, for crying out loud, and most people are going to put cream cheese or something on there anyway. So take 1 ounce of ham, put it on half your bagel. Ta-da! You just invented a sandwich. You balanced your amino acids.
Yeah.
See, that's where ham, and that's where meat, that's where eggs, cheese, milk, they have a digestible, indispensable amino acid score, DIAS. That's the ileal digestibility that we should use. They have a score above 100. That means they're a complementary protein, where whole grains are down below a score of 70. Their whole grains are usually way down in the 40s, but we can put those two together, just like a swine ration, when we balance with beans and grains, and we make a whole protein. So if you want to be a vegetarian, you have to pick your pulses, you have to pick your something that's higher in lysine than the grains you're eating. And that's how you eat like a pig. That's how you balance and make a complete protein, so you don't have to eat 22 bagels.
Although some may try.
It'd be a lot easier if you just put a slice of ham or some salmon, or pick your a food of animal origin to put on there.
I've been preaching maybe almost too much on this podcast, but I've been preaching pretty hard about the value of meat in the diet, and just because it is such a power packed, nutrient dense food that also tastes good, and I strongly believe there's probably some reason for that if we go back into evolution and everything like that. But you're hitting right on there, and I believe you've said in the past, instead of focusing so much on the amount of overall protein on a nutritional label, we really need to be looking at what's the building blocks. And to remind our listeners out there, the building blocks of protein are amino acids, and we need certain ones in our diet. And that's where meat and animal products really come into play.
Absolutely. Yeah. And on a calorie for calorie basis, we drive home that nutrient dense food. So globally, the two biggest points of malnutrition are iron and amino acids, those indispensable amino acids. So what happens in the developing human being, during pregnancy, if they're not getting those essential amino acids? What if the mom is over consuming grain-based foods? So now that blood sugar from the mom goes across the placenta and affects the baby. The baby can't use mom's insulin, so its little pancreas is producing insulin in the first trimester, and now you might be setting that baby at birth up for being obese and already being insulin resistant, in maybe not full on type 2 diabetes, but have that tissue specific insulin resistance. So by the time they're in third grade, they may be obese. So it gets really complex. And those 9 indispensable amino acids are responsible for so many things. And the downstream effects of just one being gone is really quite severe. It can be.
Well, we're not going to get into Liebig's barrel and all that other fun stuff that we teach in our introductory animal science classes and nutrition and that. But for those who have interest in this, please continue to investigate. There's actually a really great webinar on the American Meat Science Association website that Dr. Berg, as well as, I can't recall who else was on that one.
Ola from Florida State.
Oh, right. Okay. Yes. Yeah. So a few folks that talked about these subjects just a little bit more extensively, and then also with charts and graphs like we like to have, us scientists. And speaking of us scientists, I like to have a little bit of an autobiographical ending to our podcast. So, Dr. Berg, you're a descendant directly of Ragnar Lothbrok, I assume, and the no, he's chuckling right now.
Ragnar. That's my stage name.
Yeah, that's right. Tell us a little bit about how you became Dr. Berg, how you got into the meat sciences. I have a bit of a background. I already kind of know, but many of our listeners may not. So.
Well, I was kind of born into it. Many of you out there know my father, Dr. Paul Berg, who was a meats coach for North Dakota State for many, many years. I have my earliest memory of being a meat scientist is sitting on one of those stools in the meat lab, the kind that you'd spin to go up. And I was probably 6 years old, and they put me on that in front of a big cutting table full of rib cages and things, and gave me a sharp knife, and something that we really kind of frown upon with our children these days. But so I started there, and when I went to NDSU, I worked in the meat lab. Got involved with some ractopamine research, so we were doing some whole body composition and things. And I had an ag education major as well as animal science. So I started teaching for a while and really liked that. And I came back to looking for a reference from our department head at NDSU, and he said, "Well, you should get a master's degree. We need somebody to teach intro to animal science, and you could do that." And I said, "Okay." So then I kind of went down that research path, and as they say, the rest is history. From there, I went to Purdue to study different types of technology that predict body composition. Was always active in sports, so weightlifting and muscle growth was something that I was always interested in, reading how muscles grow on the side. And here we were looking at valuation of carcasses based on the muscle content and how to quantify that in a packing plant in an automated system. From there, I went to do a postdoc with Rhonda Miller, and we looked at different methods to predict meat quality in pork and in beef, try to measure marbling with different techniques. So I did a collaborative deal with the University of Texas Medical School down in Houston, and they were trying to develop a new method of mammography that was called elastography, where they use ultrasound, and it was very small compressions rather than a more invasive compressions that we think of with a traditional mammogram. And their idea was, well, if we can predict marbling in something like dense muscle tissue, we certainly should be able to fine tune the algorithms to predict benign or malignant tumors in soft breast tissue. So that's where I kind of decided that if you can think of it, you can find somebody to collaborate with. And the collaborations with people on the engineering side and on the medical side have just been fantastic over the years. And so I went to University of Missouri, spent my time there for 8 years, mostly working on pork quality type things. And 2006, moved back to North Dakota State University and been just goofing off here ever since.
I think that's a great wrap up. I like the bits of wisdom that you mentioned there too. Is collaborate, reach out, and be curious, because the answer's probably out there. You just got to run into the folks that may be able to help you find it. So
yeah, sometimes you got to get past their bias.
Yeah.
I get looked at like a goofy long-haired cowboy a lot of times. And what did you get your degree in?
Right.
All right, I want to work with you, you snob. You got to overcome that sometimes. Sometimes you got to win people over.
A little bit of salesmanship goes a long way sometimes. So
You bet. Clipboard and a confident wave will get you anywhere.
I love it. Dr. Berg, thank you so much for joining us on the podcast today. And we'll see you around.
Yeah, thanks, Phil. It's been fun.